So this is day 4, and we will be talking about resource provisioning plans. These plans actually used in many areas. One of the areas it is commonly used is in workflow scheduling. When you do workflow scheduling, you really need to first plan the tasks. You can't actually simply send it to the scheduler or to resource provisioning. It is also very much important in terms of inter-cloud usage. There are a lot of applications of pre-planning for provisioning, and we will be talking about 3 different types of plans that are appropriate for cloud computing environment. One is the common one, but the other 2 are not actually very much researched. So today we will be talking about how to actually plan for resource provisioning, because cloud providers usually offer to clients different types of resources, and these resources are provisioned based on certain plans. There are 3 major plans that these service providers will provide. I named them as short-term planning, advanced reservation, and opportunistic planning. So all these 3 are actually offered by the major cloud service providers. And I know that for sure, in particular, the last 2 are going to change and advance. But there are a lot of scopes for research in this area. I will actually put some of these problems online, and I'll talk about them today as well. We will cover these 3 service provisioning plans. Short-term plan, which is on-demand plan, which is the common one. Advanced reservation planning, which many people actually don't know, and it is very important, under-researched, under-studied problem. Opportunistic planning is a new planning that actually major cloud resource providers started. There is a lot of research in this opportunistic planning, but most of it is actually preliminary, and I believe there are a lot of them. I will again formulate a simple, provide you with a simple problem statement, and the opportunities and the challenges they bring, we will talk, and also formulate many open research problems. I have listed some, but in the middle of the break, I'll try to list some more. Okay? Do you have any questions? Anyone had a dream last night? No? No one had a dream?
Yes, I have.
So yesterday we were trying to allocate resources as per workload to various virtual machines, VMs and the job. So one issue is that one VM may have many jobs, but if a job is of such nature that can be allocated to more than one VM, is it a possibility or it is just a...
I misunderstood. I thought he was telling me about the dream. in his dream about cloud computing and virtual machine. I was paying attention, but you lost me in the middle because you moved me from dream into real question.
Dream don't sustain for long, sir. It just vanishes after.
Okay,
But
so
dreams do become reality.
that's for sure. That's why I ask you, did you dream? Because if you dream that you have gained something from here, now you can formulate the problem statement for your thesis. That's a big dream because that's one achievement, and I wanted to congratulate you. But dreams come true, and dreaming is actually very important. Remember I talked about how wives, girlfriends, boyfriends motivate each other? Dream is self-motivating actually, the most important aspect of it. Some dreams are scary though, right? So his question was, if I rephrase, one VM can have multiple tasks.
No.
And what's the opposite one?
One VM can have multiple tasks as well as one task can be allocated to multiple VMs.
No. One job
One job
can be broken into multiple tasks, and then a task is atomic. You can't actually break it. The job, if it's sequential, remember when in the first day we talked about divisible jobs, applications, and indivisible applications. The indivisible applications can only run sequentially in one virtual machine. But divisible applications, you can split them into a number of tasks, and now each task becomes indivisible, atomic, and then they run in one virtual machine. Yes, there are systems that allow you to pack multiple tasks in virtual machine, but what is the benefit of that? Right, if you the operating system, the processor is sharing between virtual machines, right? The resource, the CPU is shared between two virtual machines. So if you pack multiple virtual machines in one virtual tasks in one machine, so what you do is basically you running these tasks in the virtual machine in a round-robin fashion, right? So they will slow down each other.
It may be better utilization of virtual machine also in some cases. So for example, if some job is more IO centric and some job is more CPU or some other resource centric, in that case, the balancing can be done on a single machine in such a way that it will produce more optimized result.
Let me see what I was saying, and then we can talk about yours. So this is a virtual machine, and then this is another virtual machine. This has task 1, task 2, task 3, and task 4, as you said, packed in one. This has task 1, and this has task X, and this has task Y. So if these are mapped on one physical machine, this is one physical machine, okay? So what happened is that, because they now can use spatial time sharing, so Tx will run one, and Ty will run in this time space. Now, let's call this one TW. TW of T1 will run here. Okay? So these guys will get the slice much more than these ones. Right? Every 3 times, this task waits every 3 times. And then they slow each other. So what I was saying is that I don't actually, unless you save money thinking that way, but you pay if depending on what type of plan you used, you pay per hour or per whatever, right? If you're slowing down yourself, this takes longer, which means the cost is going up. But if you actually distribute over over 4, the cost is going down. So I don't see the advantage of packing. We can pack virtual machines on a single machine for load balancing or energy saving or failure recovery, whatever. But for any other things, I don't see the reason. Because again, remember, if you pack, these are not the same. Huh? So this could be medium or large. That's what you need. The bigger the size, the more costly it is. So I don't know. Maybe there is advantage from resource provisioning and scheduling perspective. I don't see advantage. Is that clear? Okay.
Yes, there's one more problem of choosing the tasks which can be packed together. That's again a big problem.
Yeah. So what really in a static environment, these are something called
until
keep
we are
packing.
having the same complexity on all the
Bin.
virtual machines, we are going to transferring the task into your machines.
Okay. So they actually did this before for multi-processors, where they actually packed big ones and then find another one like this, another one like that, and another one like this, and then they try to minimize these spaces, and then they shovel around, and when they get something comfortable, then they send it to scheduler. That's in a static environment, you can afford to do that. But while you're doing this, the machine stays idle, consuming nothing. They have done this a lot in parallel processing environment. Okay. Any other question? Okay. Let's talk about resource planning. Now, a resource provisioning mechanism is used in cloud computing. Now, this is all cloud computing uses this. Now, we actually don't know exactly because they actually hide. Remember, they are in competition, right? Google has its own, Microsoft has its own, Amazon has its own, and everything they do is their own privacy they protect. They think, but what we know also, they have a lot of researchers. Sometimes they come in and ask you, we will give you this and this amount of money, do research with us. But you do this research and based on something called IP. And some universities don't allow you to give out IP. In fact, almost all, I know. So, but because you do research with them, they can use whatever you develop. And you sign non-disclosure agreement, and you sign, you don't disclose until you die. So these are very, very few people actually know exactly what's going behind the scene. But we can actually submit job, and then based on that job, you can guess what really happening in there. Plus or minus, take away, something, you can actually figure out pretty well. but not in the security aspect of it, not in the number of machines they use, not in how virtual machines are deployed and all this. Okay? So, but every one of them have some sort of resource provisioning, and they use this resource provisioning to provide the clients a set of resources for their applications or for their jobs. Now, these resources, actually, you ask for what you want, right? You can say, I want a virtual machine, middle, medium, small, whatever, and how many, 3, 4 of them, whatever. Storage the same way. Now also we virtualize network, you can actually ask. And there are other issues like fault tolerance and quality of service, and all this, you package it with it. Now, because they have to make sure that they make money, the resource provisioning they use actually plans how to provide these resources in an efficient way and to utilize properly the resources and also to make money. So from their side, they are more interested to make money, to ensure that the system is utilized. At the same time, they don't want to lose customers, right? So they have some, that's what SLA is there, service level agreement is there to basically make sure that the application is actually receive what they call. So these are the different plans they provide you on demand, which I actually call short-term. Here, if you look at it, short-term planning, okay, and reserved, which I call here advanced reservation, and opportunistic, which is called spot instances. Google calls it printable virtual machines. So each one of these, particularly these two, this one, every one of us actually work in this area now on demand, because you go and purchase on demand from Google and do something whatever you want. And all research, I shouldn't say all, majority of research is focused on this part. But these are also there, and they're actually more appealing than the first one. But we're not doing it, we're not using it, we're not doing a lot of research around this area. So I'll talk about this one first, and then later on, after break, we'll talk about this one. Okay, now the model we have, very simply, we have cloud consumers, cloud service provider with its own provisioning. Now, the most important aspect of today's talk, lecture is these three requests. That if you have applications to run on the cloud, you can use one or multiple of these. Okay, you can ask for on-demand resources, or you can ask for reservation, opportunistic, or a combination of them. Okay, so on-demand instances basically allow you to pay for capacity by the hour with no long-term commitments. So basically what this says is that if you want 3 virtual machines to run your applications in the next few minutes, you say, I want to actually use 3 virtual machines of medium size or small size, and you use it, run your application, and then depending on the cloud service provider, whether you pay after use or you pay before use, you do payment, you run your applications, you get your results, you finish. Okay, so yes, they will also remember service level agreement, quality of service. I will talk about all these later on when we get maybe before Friday, after Friday, I will introduce all quality of service and service level agreement in detail. So, even though we are using this now, most of the time, this is what also cloud business model is based on. So, resource at any time, from anywhere, which means on demand. So anytime you look at the definition of cloud, the word on demand is there. So because this dominates the whole aspect of cloud computing, the last two are not actually receiving much more attention. Okay, these two have actually been migrated from this one from cluster and cloud computing, and advanced reservation is mostly done also in cloud grid computing, and it is very interesting area where you basically reserve. You simply ask Amazon or Google or whatever, I want to use to reserve certain virtual machines for 1 year. So you pre-reserve it, which means it is much cheaper than buying it right now. So according to some figures, you save about 80% or 90%. No, 80% or somewhere around that figure. Okay? Wait now. No, 80% to 90% was this one, and about 50%, 60% was this one. Now, this has a lot of problem for both service provider and the user, which we actually have to talk and do research in this space. Now, spot instance basically says Google have a lot of services unused, and they want right now. They say, okay, if they charging $2, they will say we have this much space. Now we know we want to charge you only 50 cents. So you have to bid for it. You can actually say, no, I will pay 10 cents. And another one will say, I will pay 50 cents. Now, even though we know that there are some bidding algorithm is going on, we don't exactly know what bidding algorithm Amazon is using. Because all they say is that here is the price for spot instance if you want to buy this. The problem now with spot instance is that there is no quality of service. You choose. For this, there is quality of service. For spot instance, you buy, you also take a risk. Because if somebody comes and buys on demand, they can put you out. It's not like you can't, they don't say to you, you buy this resource from the start until finish. No. We have time now, resources, come and use it, but if we get a customer who is going to pay us more, we will kill your job. So the challenge here is that how to figure out, how to predict the length of, I'll give you a lot of problem statement that you can work with, how to predict the length of the spots, so that you can actually say, oh, okay, I can use this. This is maybe an hour, my application will run for 50 minutes, so I'm fine. Otherwise, if you don't actually find things like that, sometimes you get it. You get the whole application finished nicely. But the risk is that they can come and boot you out. So we will talk about how to deal with these issues. Okay, first, these are some prices. Now, remember we said there are three of them, right? Three different plannings that they provide. This one is on demand. As you can see, it's actually divided. This is Amazon, okay? Divides it into 1, 2, 3, 4, 5, 6. You can rent the whole cluster computing instance. So you can say, I need certain 3, 4, 5 GPUs, CPUs, whatever you want to say, and I will pay. So if you see, the whole quadruple extra large will cost you about 1,300. Okay, is that $3 per hour? Yeah, $3 per hour.
So 1.3.
1.3. Yeah. Okay, so you can see the small VM virtual machine is 0.080 cents. So this is what on demand. You ask, and you get charged per hour, and then you use it, you pay. Okay. The second one is reserved instance. Again, they divide it into different sections, but they ask you to reserve for 1 year or 3 years. Okay, so you can see now the same one, the quadruple extra large, will cost you for 1 year 1,450, and for 3 years it costs you 2,225 upfront. So you pay upfront to reserve it for the whole year. Okay, so what basically you're saying is that I will reserve this, and that doesn't mean that nobody will use it. Reservation basically means you will use it anytime you want. Your job will just go in there and use it. Right? So if you are not using it, the service provider will do some work on it. Now, another challenge is that even though, see, they charge you this much amount, particularly in this issue, if the energy price, if the electricity price goes up, they have clause in there that says they will also pass that on to you. So even though you pay upfront, that does not necessarily mean this is the end of it. It actually means you are guaranteed to have these resources, but the price may change. You have heard this word, right? We'll give you this, but the price may change in a couple of weeks or so. So this is the second one. This is another one, which is actually now getting a lot of attention. Spot instances, Amazon call it. All major cloud service providers provide you with this. Spot, Google calls it printable virtual machines. Okay, so these are the prices. As you can see, 0.027 per hour. So how much you save from on demand?
0.05.
About 60%, right? Roughly, but sometimes actually I've seen about 95% also. Okay, when nobody is bidding for it and they just changing the price and changing the price. So up to 95, I have seen it. Now, you need to really be aware if you want to work with cloud computing, particularly as systems administrator or interested in working on the Amazon or Google or whatever, you need to be aware of these three different planning and how to use them. Okay, so on demand, as I said, it allows you just to get the resources whenever you want. Reservation is you reserve an instance for 1 year or 3 years, one-time payment for each instance you want to reserve, and actually you receive a lot of discount. A spot instance is what is hot now in research areas, but there is a lot of issue with it as well. We will talk about this later on. I will start with advanced reservation planning. Now, most of the provisioning that we do now, it is on demand planning. Now, this is different. There are many applications that actually need a reserved bandwidth, for example, in interactive multimedia, right? Otherwise, what will happen to the image? So they have to come in proper sequences, and they can get out of sequence, right? That's when you see jitters in movies and so forth. So these kind of applications require really the end-to-end reservation of the resources. Also, there are many organizations that actually need to reserve certain portion of the system for certain period. Now, even though that the cloud computing environment as it is now, they push you to reserve for 1 or 3 years, very soon this will change. Okay, it will actually come close to on-demand planning. So that's why I say I see a lot of research in this area. Advanced reservation technique is also very important in multiple clouds that are federated clouds. They call them interclouds. We call them hybrid clouds, by so many names. They're very important because if you actually using 3 different resources from 3 different people, then you need to reserve them before you use them, right? Otherwise, you can't use. So you can see that reservation has actually, advanced reservation has a place in multiple cloud usage. Now, you actually need to clearly understand what you need. This is a research problem that you can actually think of. Many people actually don't know exactly the amount of resources they want. They usually overbuy or underbuy the resources. Now, because it is much cheaper compared to on-demand planning, people start now paying attention to advanced reservations. As I said, all major cloud service providers provide you with reservations for 1 to 3 years with a fixed charge one time. Resources can be reserved and launched at the beginning of stage. So there are many stages actually to the way you deploy, which I will talk about, and then terminated at the end of the stage. So these stages are basically sometimes you buy, you reserve the resources, and you use it. If you overused it, then you actually pay extra because on demand usage, if you actually wanted that, and then you move back into another stage. So if you overused it and then automatically get on demand plan, then you have to pay for it and move back again. So there's the different stages that you go through. how can we develop such advanced reservation algorithm to enhance user experience? So the most important thing in advanced reservation is to make sure that users are guaranteed that they will use the reserved resources at any time they want. And users can have, can experience a good quality of service. Now, the issue is sometimes these systems fail. Okay? In that case, if your application actually demands in certain locations have to run there because the government says your data can't move to another location, you can't do anything. The only thing you can do is to use another person's resources to ensure that this will not happen. Okay, two challenges that advanced reservation can bring. One challenge is the under-provisioning, which is still open research problem. As a user, we don't actually know how much we need, right? We can guess. Remember, we said that sometimes the workload goes up, sometimes goes down, sometimes goes up, sometimes goes down. So how much resources you need to reserve? So under provisioning problem can occur when the reserved resources are unable to fully meet the demand due to its uncertainty. There is uncertainty, right? Because I don't know how much I need, and uncertainty also from the resource service providers, because they can't guarantee you 100% they will always be the resource will always be available to you. But from user's perspective, they can actually do what? If they under reserve, they can always go into on demand, paying higher price, and use it. Now, but the original purpose of reserving in advance is what? To save money and to make sure that their application will get the attention it needs. Now, if you always believe that I will go for under, and then I will go into on demand, what if on demand resource is not available when you wanted it? So then that means your application will not complete. Even though there is possibility that you can actually provision the resources you need based on demand plus reservation, there is an issue here. Okay, you pay more and it's not guaranteed. Now, the problem of over-provisioning is you buy more than you need. Again, this causes what? More cost to you. So if you look at both ways, you pay more, right? Now, the idea of advanced reservation is to minimize both of these. Okay? So here is the different stages that application runs in. You first reserve the resources you need. That is stage one. And then if you actually under reserved, then you can actually extend into on demand provisioning. And then utilize the reserved resources and then extend to under on-demand phase, provisioning, and then you use it. So if you look at these, resources are reserved in advance, prices and demands are observed, and then the reserved resources are insufficient, you go on and get that. And so what? Then you cycle through this like this. So at every stage of execution of the application, there is a demand for resources if we actually underestimated. So the costs that we have reservation cost. When we want to do advanced reservation, we need to determine the cost of the reservation for provisioning the resource types. Now, you can remember I showed you the tables. There are different types of resources that you need. So we need resource type, which is and requested by the user applications. And given this information, we can actually determine the cost of the overall cost of reservation. Here, the capital R is basically a set of resource types. So we have memory, network, storage, CPU, and all this is in R, capital R. And these are provided by the cloud provider. BIR is the amount of resources of type R from here required by the virtual machine in class I. So if you use virtual machine, for example, the classes are small, large, big, extra big. So class I, of course, each of them costs differently. So that is what BIR stands for. CR, this is the cost of resources of type R. Now, if you have 3 resources, then you will get the total cost for reserving these resources. Okay? Here is an example. For example, an end user reserves the following: medium and extra large virtual machine. And the medium one is 3 of them, and the extra large is 2 of them. The cost for the medium is 132, and the cost for extra large is 520. If you plug that in there, this becomes 3 by 132, 2 times 552, and you add up this, you get the amount of cost of the reservation of these resources. Okay, this is assuming now you're reserving for 1 year or for 3 years. Okay, now then we have the stage 2. If you under reserve, right, but you need more resources, then we need extra reservation cost we incur. And this we need to take into account the case where under reservation can occur. In this case, when under reservation occurs, we need to provision resources from short-term planning. And the extra cost in this case is basically like before, but now how much time you use the extra resources, and this gives you the amount that you incur extra. So now we have 2 costs, right? The reservation cost, the possible extra cost. Now the reservation cost can have exactly what we want, or we over provisioned, which means it's not maximum. We pay more. So if you look at this, the cost for over reservation is C over, and the cost for under reservation is C under. Now the total cost to the customer is C over plus C under. And now the aim of the resource provisioning algorithm that we are developing is to minimize C total, this cost that incurs. But there is constraint. These are the constraints. The consumer's demand for virtual machine are met. So if the consumer says, I need 3 medium virtual machine plus 2 small ones, then I have reserved it. I should be able to get it anytime I want. So this is constraint number 1. And maintain the amount of extra resources utilized to be less than or equal to the number of reserved resources. So what this says is that if I ask 3 and 2. If I go on demand, I should not actually get 7 small ones and 6 large ones. It has to be in the same amount that I ask. 3 medium ones plus 2 small ones. Don't give me 7 small ones. Okay, that's what that says. The allocation of resources for virtual machines must not exceed the maximum resource capacity. So what the third one says is that you can't actually assign to the user more than you have. The resource provider has limited number of virtual machines. They can't actually provide, if they have 7, they can't provide 10. So these are the 3 constraints or restrictions under which we want to minimize the total cost. Is that clear? Okay. So as I said yesterday, when you actually prepare your proposal, do it in this manner so that your supervisors will understand, and you also save yourself a lot of headache. And then you don't actually also become Superman also, try to solve something you can't. Okay, this way it becomes very simple, very easy to see for me to address it. And I know what to address, what to solve, what to maximize, what to minimize. Sometimes you try to impress your supervisor, and you come up with very, very nice and big problem, but that problem is unsolvable. This, even though I described it very nicely, this problem is called NP hard. So don't think this is solvable. It is very, very difficult problem. But at least from what you see, you can see that you know what to solve, you know what problem to attack.
Practical one small issue is there, as you mentioned in this. As you mentioned in this, that in practical there is one small issue. For example, suppose I reserve some resources, it is under provision, or my estimate is not up to my
Out of work.
But I am not aware of the capacity of the virtual machine provider. But my job is so big that at the time when I start running, I need so much resources that is not available with the service provider in that segment. The job is not done.
Well, I said one of earlier, if you remember, one of the options is for we have to have a mechanism that will say you are out of your resources that you reserve. Would you like to actually now go on demand or kill your applications? So there was a lot of problem when Amazon started these spot instances. They don't tell you that they're going to
What
kill.
capacity they are having?
They don't tell you. You just buy for 10 cents, and then they got a customer. They will kill your application. Now they give you 2 minutes. So they send you a message and say, you have 2 minutes. What to do with it?
Take decision.
They will kill it. So if you reserve, I believe they should be able to say to you, you exhausted your reserved resources. You should now, or you can build into the contract, if I run out of the resources I need, you charge me, I'll use it. Now the research question is, how do you know you run out of resources? And how do you know how much you get charged, how much resources you used? Yeah. Any other question?
Sir, we can decide whether we can run in predictive manner or non-predictive manner.
Because there is a lot of noise here. Speak up.
Sir, we can also decide that whether we will run in predictive manner or the non-predictive manner. Right? So we can decide on it that you cannot kill my job, I will pay more or something.
Yeah, you can build that in the contract. But the whole idea of reservation is you believe that you have reserved enough because you don't want to reserve more and you don't want to pay more.
Actually, sir, the main thing is the uncertainty that I will get that.
Exactly. That is the at the heart of the problem is the uncertainty. Unless you one of the open problems that I put when we get there, you will see is how to predict how much resources I need and how much, if I exceed this, how much resources I will consume. So if you can say 80–90% sure you predicted correct, then you can actually come close to the amount of resources you need. Otherwise, there is uncertainty from both sides, provider side and consumer side. Is a big problem, particularly in multiple cloud, federated cloud issues. Okay. Now it's important, as you can see, that the resource provisioning algorithm that we design will always try to minimize the total cost by reducing the on-demand cost in particular, and also by reducing over-subscribed costs of under-provisioning and over-provisioning. Now, you can actually reformulate this problem as a problem of over and under-provisioning. Okay, so the other cost, which is if you use exactly what you want, is a known quantity, right? Because you prepaid. But the unknown parameter in here is how much you exceeded or how much you underutilized. So these are actually what you can frame this problem in a different way. So I can actually frame this problem in at least 4 or 5 different ways and get 4 or 5 different solutions for it. So he actually said yesterday, everything I see, that it seems to be solved. But it is actually the way you frame it. You can frame this as under-provisioning and over-provisioning, take out less than the amount I'm supposed to pay, which is known quantity. So how can I find the unknown quantities in there? Is another way of framing the same question but solving different problem. The algorithm should also consider both the demand uncertainty that he was talking about from cloud consumer side and price uncertainty from cloud provider side, right? Because there are uncertainties. The whole problem of advanced reservation is the issue of uncertainty. Okay? Any other questions?
Is it depend on the experience of the customer?
No?
Sir, it is about the uncertainty of how much time it's going to take to complete the process. Right?
No.
What
Many uncertainties from user's perspective.
No.
When do I need the resource? How much resource I need for my application? So these are just 2 of them. Okay? From the cloud service provider is the price. Say, for example, the energy price goes up, which you didn't factor in, and they will charge you. Or they're using the pricing mechanism based on supply and demand. By the time you request the resources, extra resources, there was high demand. They may not actually provide you, but they don't want to lose you because you are an important customer. What would they do? They will charge you more. Okay? And there is another issue, but this issue, I don't know if it happens in cloud environment or no. It just issues that happened to me. I needed my laptop is repaired. It has gone from 5,000 to 15,000 rupees. So it's going up. It's exactly so they can do, if they know that your application is very important must be finished, they can actually say, okay, we will charge you, we'll boot out some other people, but we will charge you 3-4 times of what normal price is. So that is uncertainty there also. But there is a lot of uncertainty. Another uncertainty that you can find is resource failure. Something will happen in the data center. And what would you do with that? You need to pre-plan for that, advanced reservation of another level. Okay, so we are talking about only one service provider. Now, if you take this uncertainty into multiple cloud service provider, which many people now call it intercloud, federated cloud, and so this multiplies, this uncertainty multiplies. Did I answer your question? No. Okay. Okay, remember the stages I showed you, the different stages. So now, you actually remember when we said that when you reserve for 1 year, for 3 years, you write a contract, right? And then you build into your contract issues like this uncertainty, how to deal with it. Okay? Now, here is simply you have single contract. These could be multiple contracts if you have one service provider. But if you have multiple service providers, it becomes multiple contracts. You can also have multiple contracts with a single provider, right? So you can have a contract for having a cluster, and you can have another contract for storage, just storing your data, and the cluster is for computing of heavy, batch, whatever oriented applications. So what you see here is that the reservation decision is taken for each contract duration. So this is one duration, 1 year. Okay? So as I said, this is actually now one of the problems that you should work on. So you see this one year or one period is the rating, okay? The contract duration, it is one contract duration. 1 year, 3 years, 6 months, whatever. But this is actually the number of reservations you made. Okay? So you can actually look at it in a different way. The number of times you used. You reserved the whole thing, right? So this is how much you used, and then you stopped, and then you used again, and then you stopped, and so these are segmented. Purposely, we segmented it in this way. Okay, so we divide the whole duration. This is T. We call this T into multiple segments. This is one segment. This is another segment. This is another segment. This is another segment. This is another segment. So partition your whole 1 year, let's say, into 3 months, 3 months, 3 months, 3 months. Okay? Now, each one of these from here to here is called segmentation, the duration of segmentation as TK. Okay. Now, let's look at for single contract. One contract. This is the demand vector, but now the demand vector is basically the requests you demand. You can demand 1, 2, 3 resources or whatever your requests. So there is this is the maximum from here to here, the T, okay? So the maximum demand is there, and this contract is only one because we're dealing with a single contract of K time period. So this is K time period from here because we say it's TK from here to K. How many segments we have? And we need only one. See, that's why TK, K is many segments, but we're dealing with now one contract only. Now, this is T, as you see, the whole year, yeah? The whole program, the whole stage. TK is the duration of contracts in stage 1. So in here, if you see in here, what this algorithm does is basically try to find the smallest one. In here, you see here. So in here, it wants to find the smallest possible. The algorithm is to find the smallest element of the segment of demand vector that is covered by the contract. So this is one contract. The smallest segment in here is what? Okay? And then the whole this here is basically it wants to find the smallest segment. And in here, the selected smallest segment, the decided amount of resources are reserved at the beginning of that segment. Okay, so you find the smallest segment, and then you reserve that segment. It didn't make sense, right? I'll say it again. So we have 1 year. So this is the whole time period, right? And we partition this into some unequal segments. They are not equal segments. So what we're trying to do is that we want to reserve some block of resources. Okay? So we have a contract from here to here. So anytime I come, I will use this amount of resources. One of the problem is under provisioning and over provisioning. So what do we do to minimize that? Is to find the smallest segment. Now, when you write a contract, you don't actually get this. You only get T. So what this algorithm is saying is that partition this into some segments based on some historical data that's available. You see that the curve like this, that is actually what you already have seen this before. So based on that, see they are something like this, and then you partition this into something like this. Okay? And if you use this one, you may be over provisioning. If you use this one, you may be under provisioning. So the idea is to find the most suitable one, looping through each one of these, finding the most suitable one, and it says reserve it. See, reserve at the stage S. Which stage is appropriate? Okay? Don't be scared when you see things like this. It's basically straightforward. algorithm. Is that clear? You want me to explain more?
Yes, sir.
Yes? Okay. Where? Which part?
Here for every segment separate. We are doing reservation for every segment separate, not for all duration. Yeah?
No, we just want it for each segment, yeah.
Then we don't face this problem of over provisioning or under provisioning.
Why?
Because we are taking only one segment.
For one contract. For single contract. No, we divide it into segments
Yes.
based on historical data.
Yeah.
And I wanted to actually just reserve for what I need based on this information.
Yeah, but we will reserve in different time, different resources or no for the whole duration according to these segments. I will reserve resources. You need to identify what resources you need. Yes.
Okay, say you need 3 small and 5 extra virtual machines.
Yes.
Okay, so that then you want to reserve that for a period of time. So these are actually segments that we create based on what we observed before. So if I actually need 3 and 3 and 2, if I reserve this, yes, I will actually get under provisioned. If I get this segment.
But I am saying, can we reserve that I need from, in this month, for example, I need 2 small. In this month, I need 2 small and 1 large.
Yes, you can do that.
That's what we are doing here. Segmentation, for example, for every month.
Yeah.
And in second segment, for example, I will say I need only 2 small.
Yeah.
In next one, I need 2 small and 2 large.
Yeah. But that's not what we say. What you trying to say is that every month you wanted to change. No, but you are not allowed to do that. Then if what you're saying is true, then we can actually have a different algorithm.
Yeah. And we got
That will be a
now-
short-term provisioning.
Yeah. So no, they will only allow you 1 or 3 years. So you have no, once you get into that, you can't get out of it. But what you're saying is what I was saying earlier, if you remember, this will change. This 1 year and 3 years requirement, eventually when people actually start making noise, why I have to reserve for 1 year, and then people will actually start pushing the business model and change it. But as of now, you can only reserve for 1 year, or the minimum is 1 year, the maximum is 3 years. And as I said, they also probably they would increase. Sometimes they call index increment, whatever your food increases. It's not like GST. Food increases. Electricity increases and all this, then this also creeps into that. Now, if you have 1 year, how do you actually use properly this 1 year period for one contract? That's what we say. If the system allows us, I need this month 2 small one, I need next month 2 large one, then it is good for us, but it's not good for the service providers. They will not.
He take advantage from the waste of your
Yeah.
resource.
Yeah. So what they trying to say is that we want to prepay, to get prepaid for these services. Remember, that doesn't mean that nobody will use what you reserve. This is the only time when you say you're going to use this. This is the only time that the service provider will not touch your resources. But while you are sleeping, they will use it. Okay? So that is what we try to address, this problem of I need these resources right now, but I want to use the appropriate amount. Now, you can actually do this also for multiple contracts. So, for one contract, then for multiple contracts. Now, for multiple contracts, basically you use this one. This for one contract, you call this one contract, single contract, and you try to reserve one at a time. So if you have 4 or 5 contracts, the single one has solved each one of them. So you call that, you solve whatever possible. So if you have 7, you call single on all 7. Single will say, I have solved 4 of them, but 3 I can't solve. That is this part. See, this part, after considering all the available contracts, the remaining demands will be fulfilled from the on-demand resources. So I am able to use this. Now I can't use, so you move on and say, okay, now can I rent it? Not contract it, rent it. And you rent for the duration you use, and you pay for it. Remember the 2 steps that I showed you? You can rent it. That's basically the extension of the smaller one, the previous one, by adding that level of steps.
Here only reservation.
Yeah.
Next one, reservation with on-demand.
Reservation plus extra demands. Okay? And for multiple contracts, not only one. Now, this is simulation analysis, and it is based on what Amazon charges you. The tables I showed you, remember? That earlier you saw that the figures for the price, it is based on that, and we actually the algorithm used for 1 and 3 years, but this is scaled down, okay, because the algorithm uses the trace, the application trace that is collected for workload archives in these 3 places. Based on that, the simulation is based on the traces of the applications. Now, the problem is these traces are only for 1 month. These are for 1 year and 3 years. So there is a speed scale down applied here. So instead of 1 year, the algorithm uses 1 month. Instead of 3 years, the algorithm uses 3 months. Okay? So there is proportional scale down, as you can see here. Instead of for 1 year and 3 years have been scaled down to 1 month and 3 months by doing this. Very simple multiplications and additions. This is the trace data of the application. And you can see that this one is without reservation, okay? The red one, no reservation. And this is, see this one, the bottom one, this one is used as a benchmark. This is an algorithm called optimal. As I said earlier, remember, it is an unsolvable problem. But we know exactly what the output is. The optimal is unrealistic. You can actually test it with your optimal. But you make sure when you write in your paper saying this is an optimal, and it is unrealistic. Don't say I did it. The optimal, anybody can do it, okay?
It's very easy.
Yeah, so, but it is not realistic. You can't solve it. Because,
It will take too much time and memory. What I tried to solve one problem for only 50 VMs
Yep.
with 4 constraints. It needs 500 GB memory.
yeah, yeah. But you can actually imagine that it does it and say this is how much time it takes to do it. So that is the algorithm. This is optimal. This is not realistic. This is not doable. And you can see the next one is multiple contracts, and the red one is single contract. So the red one is the one here for single contract, and that one is for multiple contract. So the cost is, this is the cost. You can see that as the time increases, the cost also goes up. Okay? So it is nicely tracking the optimal algorithm. Now, they look like matching, they don't match. Because of the numbers. These numbers, you see, because of these numbers is logarithmic, they look like they're actually matching. They're not. The optimal is the best, the excellent one. The others are far from it. So you can see that this one without reservation, the cost is more expensive. So that's why I said reservation in the next few years will be one of the hot topic, advanced reservation. You can see that by reserving and sometimes mixing with on-demand, you can improve the outcome of the...
Minimizing the cost.
Yes. So this is where a lot of research is going to come. Now, this is for the second application. That one was for another application. And this is for Sandia National Lab application. And again, you see, without reservation is very bad. Right? So, with reservations, you can see it is just tracking the optimal one. Now, in percentage, the increasing cost of different types of reservation strategies, again, compared with optimal, you can see that no reservation for 1 month is about 24, for 2 months, almost double, and you can see that for 6, it goes to 60. Single contract, there is substantial decrease. You can see that you can basically track if you look at this. And this is duration per month, 7, 8, 9, 10, 11, 12. Continue from there. You can see again there is a nice decrease in percentage-wise. Okay? Now, overhead is another problem. You can see that in microseconds, the overhead that different strategies experience. Single contract is about 271 microseconds. And for 2 months, it is 46. And for 6 months, it is 710. And it goes like this. For 12 months, it is 1123. As you can see, for multiple contract, as the months increase, it doubles. the overhead, because we need to go through loop through each contract, and then if we can't find, we have to go on demand and do it. That's why it doubles the amount, the overhead. How can we integrate the various uncertainties into the algorithm? Now, we actually didn't take into account the uncertainties. So it's an open question. How can you actually integrate the various uncertainties into advanced reservation algorithm to reduce the cost, whether it is actually over, under, provisioning, and whatever? How can you do it? Okay? Can integrating the option of spot pricing, I will talk about spot pricing after break, very shortly, because I think it's now almost 12. Can integrating the option of spot pricing scheme further minimize the total cost? Okay, so instead of on demand, remember we said there are three, right? Spot instance is opportunistic use of resources. So if we actually replace on demand by opportunistic planning, will the price decrease? Because on demand is the most expensive one. If we take that out and put opportunistic planning, how much we reduce? Remember, the opportunistic one has also side effects because they can boot you out.
They are not available for all time.
Okay? Any questions for me? No? If no, we'll take a break, 10 minutes break, and then come back and we'll talk.
अपने को नहीं देते हैं ये करने लगे होते हैं आप लोगों को ये बंदा नहीं तो लगता है
Okay, let's continue where we left off. Now, another set of open problem is the work so far tried to maximize social welfare. So we are actually looking at the end users' welfare. We wanted to minimize the cost for them. The other side of the coin is how can we maximize the revenue for the cloud provider? Because one of the reasons they provide advanced reservation is they guarantee the revenue for at least that period of time, right? So the other question now is how can we actually improve this to increase the revenue for the service providers? So we need to look at both sides of the coin. The fourth question that I have here, many existing work only look at a single cloud. So many of the solutions that are proposed now are just for single cloud. The way things are moving is into multiple clouds. So how can we extend these algorithms to multiple clouds? So advanced reservation for multiple clouds. How can we do it? So it could be using some resources from Amazon, some resources from Google, and some resources from Microsoft. So it could be the same resource, hardware, okay, as infrastructure as a service. It could be different resources from Microsoft, the software, from Amazon, the infrastructure, the hardware, and from the Google. Yeah, so you can have the same identical resources, different completely resources, but mix and match also these resources. So you can actually break this question into many sub-questions. Okay? So this is another set of questions that you may be interested in looking at. There are many work that statistically determine the amount of resources to be reserved in advance in order to minimize the total cost of running an application. There is a need for extending or proposing new approach that dynamically determine the amount of resources to be reserved in advance in order to minimize the total cost of running an application. So, again, because cloud is dynamic, can you come up with some way to predict the need for resources? This is how much resources I need, and I shouldn't actually over or under provision myself. So this basically wants to do this in a dynamic fashion, and so to minimize the total cost of running an application. Can we predict how much resources I need? Okay. So I think this set of questions will be enough in terms of resource reservation, advanced reservation, but there are many questions that you can see in this space, particularly in the next few years. Now, spot instances. This is actually, many people work in this area now. Many papers are there. Many more problems actually. So basically, what spot instances is, as I told you, when Google, say for example, have underutilized resources, they entice people by saying, here is what we have is almost next to free to use it. Now the important thing to understand is what kind of applications is suitable for spot instances. This is one of the questions you need to really look into it. It's not all applications suitable for spot instances. Now, spot instances are resources that are opportunistically exploited, opportunistically used. Okay? You can buy for an hour spot instance, but spot instance is interruptible, preemptible. On demand is you are guaranteed, right? Guaranteed in a sense that whatever plus and minus of service level agreement that you made with the service provider. A spot instance is different. So, as you can see, a spot instance can only be launched immediately if there is available capacity. Okay? And you can also see the hourly price for spot instances varies based on demand. So if there is no demand, the price keeps going down and down and down to probably 95% of the on-demand price. Spot instances can be interrupted, right? So while your application is running, the service provider can interrupt your application running in the spot instance. Now, many major providers do provide the spot instances, and mostly these are useful in applications such as batch processing, high performance clusters, as well as web server fleets with variable workloads. These are some of the applications that you can use. Okay? Now, you really need to highlight when we say some of these applications. Now, what makes spot instance appealing is you get a lot of discounts. Okay, so you just got this spot instance for, let's say, $2, but the price is now fixed. So now if the demand increases, the price goes up. So what happens is that your application will be interrupted. So there is no guarantee that the price will go down. The only time that your application will continue running for that hour is if the price goes down. If the price goes up, because the price fluctuates with demand. If the price goes up, you lose. The other element of spot instance is the service providers will simply say, we are now allowing spot instances, and then you bid for it. So there is a lot of bidding algorithms that are developed. Well, it is what in our case what we did is that we developed bidding algorithm for e-commerce environment, and we simply ported that into a spot instance. So we converted the algorithm for a spot instance. Now, even though there are different types of bidding algorithms going on, there are money auction algorithms. These auction algorithms exist for many years. There are many that are implemented for spot instances. There is still a lot of problems, many problems to address in this area. So there are, at least if you can see, there are 3 different ways. One is the service provider initiates bidding. So that is an auction. So there are research questions around the auctioning and buying this service. The second problem is, you can see there is also major applications that can use this. So any application that tolerates interruption is okay. But application that doesn't tolerate interruption is not okay to use. And the third, from the other angle, if you look at it, is how much are you willing to pay? Because if the value of the instance, spot instance, is fluctuating, you want to get, it's just like buying what you call stock, right? Stock on the stock exchange, like buying. Sometimes you win, sometimes you lose. But experts in this area are the ones who tell you buy now. It's time to buy now. It's time to sell now. Okay, because now many people are like Professor Zahir said yesterday, we are focusing on crypto coin money to buy and sell. It's the same thing here. But how can we actually predict? My feeling is that the service providers know exactly when the price is going up and going down. So the more they're going down, you can also see that there is no demand for it. And sometimes purposely push the prices up. So you can come back and say, okay, I will pay. Now I can go into on-demand instance, or demand provisioning or planning. So can we actually determine from this side as well? Now, issues with spot instances, as I said, are cost-effective choice, flexible about you when your application runs, and if your application can be interrupted, and spot instances are well suited for data analysis, batch jobs, background processing, and optional tasks. So, like data analysis takes a long time, right? It crunches, like if you take the text analytics, it takes a long time. Interruption here and there will not affect it. Okay? Before, Google used to kill it. What's his name? Amazon used to kill it. But now, there are things like you can do checkpointing. Your virtual machine can be checkpointed. You can checkpoint, and then when again spot instance is available, you run your disk. Now, can you see a research question in this? Now, my application is interrupted. I checkpointed my application. Checkpointing means store all the execution environment of this particular virtual machine, and I will store it. And when another spot instance is available, I will just bid for it and then come up and use it. And then when the warning 2 minutes comes in, I checkpoint and store it.
So who will store that, service provider or customer?
You. In Amazon, you are responsible for everything. They will simply manage. If you have data in there, they will manage. If you rent something, they will guarantee at least certain level guarantee that it will be available. But in spot instances, there is no service level agreement. All they saying is that here is the resource, but this resource is interruptible. No service level agreement. Use it on your own.
Risk.
Huh?
Risk.
Huh?
Risk.
Yeah, on your own risk. But as I said now, they also provide this checkpointing. Checkpointing is not a new area, but it's still, there's a lot of things to do in that area as well. But the service providers can provide that as a service also for extra charge. There is nothing free. Okay. Now, some research question is spot instance offering an SLA governance. As I said, there is no SLA, right? So, although the availability of service SLAs is a core paradigm in cloud computing, the business model is based on service level agreement. So, is it possible to develop some sort of probabilistic model to actually provide some SLA for spot instances? Can we come up with probabilistic approach? At least to basically guarantee that the instance service to provide eviction probability, right? So if I'm running my application, if there is higher, the price goes up, my application will be evicted, right? Will be interrupted. Can we come up with probabilistic model to simply tell me that my application will be evicted very soon, or your application is not suitable for this spot instance because it will be evicted before it completes? So can we do this? The lifetime of spot instances are unknown quantity in the provisioning of cloud services. Basically, the lifetime uncertainty of spot instance makes their use very difficult to end users. Can we develop a predictive algorithm that can predict spot instance lifetimes? Can we develop an algorithm to predict the lifetime, how long a particular spot instance can last? Okay, without interrupting. How can we integrate the predictive algorithm with the resource provisioning to ensure that all accepted spot requests meet their target lifetime. So in other words, can we develop the, what is it called? Admission control system. So if the system knows that you bid for spot instance, but it cannot satisfy your application because of your application is beyond the spot instance lifetime, then it will reject that application. So this can we develop something like this? Admission control system for spot instances. They do it now. Google actually, cloud service providers have admission control system. If they have, if they feel that the SLAs of the existing applications are going to be affected, they will not admit additional requests. Can we do that for spot instances? Okay. Now I am actually talking about this. These are new research. Nobody did them. I just now removed the auction ones. A lot of people are working in that area. So if you are interested, I can give you that one also. Now, a spot instance will be terminated if the capacity is needed to run an on-demand instance. Developing SLA-aware resource provisioning algorithm that effectively co-schedule. Now, we want to actually co-schedule this with on-demand and reservation. So to ensure that my application will continue running. So is there a way we can actually develop a cost-effective co-scheduling algorithm that links, integrates on-demand workloads with spot workloads to provide guarantees to utilize otherwise unused resource capacity? So opportunistic, mixing opportunistic with on-demand or available, always usable resource mechanisms. As I said, I actually removed bidding. I find it a bit mathematical. We can attempt to predict spot instances lifetime based on the recent history of cloud activity. You can actually. So this is one way of thinking of developing a new algorithm. Past work has shown that cloud workloads can be highly variable and may not be easily described by single well-known probability distributions. So I suggest online simulations. So if you want to actually come up with algorithms, simulations such as Monte Carlo simulations that run every few minutes is a better algorithm or a better model to see, to develop spot instance eviction time for requests. Well, I think that's all for today. I'm happy to entertain any questions you have. It's 12:50. In 10 minutes, lunch will be ready. Any questions?
Sir,
Yes.
suppose I am running my application on cloud and 50% of this application has been computed, and now the resources has been preempted by the cloud service provider, right sir? Now I want to know when the resources will be available again, then my application will start computation from 51%.
That's
Or
what
from
I
zero.
said.
Or from zero.
No, that's what I said. Checkpoint it,
Yes, sir.
and then once you checkpoint it, it will just start from where it stopped.
Exactly 51, but any point, checkpoint.
Checkpoint, yes.
That would be possible even if we migrate it to some other cloud.
Yeah, it is because virtual machines are migratable, and you can do that.
This should be very much possible because there is always some time, recovery time or starting time of new application.
Yeah,
That provision.
yeah, it is possible. There are a lot of problem scopes for even doing this migration thing. A lot of overheads there. I worked in this area for many years in fault tolerance. When I developed fault tolerance resource provisioning and management, it seems easy, but a lot of unsolved problem. Especially now with virtual machine migration, there are overheads, there are issues that you need to take into account. Any other questions? Girls never ask questions. They pretend.
In case of some interruption or the payment that has been made will be reverted. I mean, if the interruption occurs in on spot.
No, on spot instances, the agreement is that there will be interruption. So you actually agreed to that. So it will be interrupted. You already got what you pay for, 90 cents. You're supposed to pay maybe $90, you pay 90 cents. You already received your service.
Okay.
Okay? So by reducing 90%, 80 to 90%, you are gaining. But the whole idea also, because they are building bigger and bigger cloud data centers, this spot instance is going to be one of the hot areas. A lot of underutilized resources. This is why they came up with spot instances in the first place, because they have a lot of underutilized resources. And they want to actually make more money, increase the utilization.
So that can be on the provider side. Because
Provider
they can
side.
actually manage it that some other site is being vacating soon, so they can provision it,
Yeah.
that they can reschedule it over there.
Yeah, yeah, that's true. But as I told you, we want to look at both sides, right? We want to look at the providers' maximization of revenues, the welfare of the end users as well. When we do research, you don't have to focus on both sides, but there are problems for in both sides.
Now, in fact, it should be from the provider side, because ultimately they are going to use your model for their own benefit.
Yes, that's true. Even if you develop for user side, they will actually use it.
But also from user side, there are many problems in this broking.
Such as?
Means there are too many research they are doing in this broking strategy.
Brokering.
Yeah, broking.
Yeah. From the how to submit.
From user.
Yeah. Yeah. Yeah.
Admission control.
How to minimize the cost and how to get better quality.
Yeah, but what I told you, remember, this prediction part of it is nobody is looking at it. And dynamicity is not actually looked at it. We can always see, come up with some algorithm about improving it. But also if you take these factors in it, it becomes really a very interesting and challenging problem.
Sir, suppose we are developing a model for minimizing the cost from the customer perspective.
Yeah.
Then how it is possible for the cloud service provider who want to maximize the cost that he will use our model?
Because you bring them more customers. Reducing the price with more customers, still the provider makes more money. So
as a provision to
yeah, it's economic model. So
When price
Yeah.
increase, demand increase.
Yeah, so you bring more clients. That's good. You did something good
You
for them.
already have free resources.
Yeah,
But
Yeah.
quality of service may decrease about
quality of service cannot decrease. It's not already there.
Already we are developing.
Because almost in all papers they mention that in all papers that they mention that resource utilization almost 20 to 30% usually.
Utilization is a serious problem, but slowly cloud resources like big, what we call killer applications, are actually being moved into cloud data centers. These killer applications will actually take a lot of resources, but now small applications like queries, web service queries, small ones that goes for microseconds to seconds, a few seconds, the utilization will not go up, right? Unless you have killer applications on the resources. It's the same. One of the reasons actually we move into different frameworks or models is, as I told you the first day, the car, you buy car, 80% or 90% of the car's life is just sitting in parking lot. So people are thinking now to change. That's Uber is actually one of the model they use, business model is to change this. Now people are talking about sharing cars. So the business model is there, the utilization is the one that's driving some innovations. In computing, most of the resources are underutilized by 50, 60, 70% of the time. They are not used. So the idea of grid computing was actually to scavenge opportunistically those unused resources. Say when India sleeps, people from America can use the resources here. When Americans sleep, Indians can use the resources there. That was the idea of grid computing. But the model is not actually based on business model. The model is based on the need of poor people, not the rich people. Rich organizations, big organizations that are happy to pay money and use resources. So that is why it didn't fly. Any other? Where do we go from here?
Lunch.
Lunch, huh? I'm talking about research. Yeah, it is 1 minute to 1. So you are right on time. Okay. All right, I'll see you after lunch.
Workload size means that the workload is rated as a hyper distribution. Hyper exponential. Hyper exponential. Okay. For this, we have first of all use CloudSIM example 6, in which in example 6 there are 20 virtual machines we have taken here, and there are 40 cloudlets. Now we have to decide what is the length of the cloudlets. Cloudlet means that workload. For deciding the size of the workload, we use the hyper distribution. For this purpose, we have to change here.
We will make the codes available to you right now. So the first thing is you have to go into the cloud data center. And in there, they fix the date, the length to 0 point something, and also the arrival time to 0.0.
Now here for calculating hyperdistribution, we have taken the value of probability. We have two values, max value and min value, initialized. Then we create a random method. Max value. Text size, increase the text size. Just a minute. Control plus. No, this is not working.
Control plus.
Appearance. Just a minute, I have research.
While he's doing, I'll tell you what happens.
Window plus.
So in cloud sim,
Window.
cloud sim,
Window plus.
control plus है.
Windows.
Control plus only.
Window and window size.
Like that, control plus only. Now this is.
if I talk, nobody pays attention to me. So I'll wait until he finishes.
Window P.
Now, click the side of Now this is okay?
Yes.
Okay. For implementing hyperdistribution, we have taken two values, max value and min value, and a random object is created for generating random number. For now, this is the probability generated. This is the variable named probability, which stored the random number. And sir told yesterday that lambda, the value of lambda we can fix to 0.2, and value of workload we can fix 13.76. This is just a message for printing. Now for calculating the length means the workload size. This is the formula for calculating hyperdistribution. Math dot ceiling probability this, and multiply 1 minus.
This for small and big.
For
Small and large.
I think everybody has this formula, right?
I have just.
लेक्चर 3 में होगा विकास.
This one.
This is the formula for calculating hyper. This is the formula. By applying this formula, we calculate the length of the cloudlet having different size. When
Do you see the line I highlighted there?
Yes, sir.
You will see in the, was it the day before yesterday's or yesterday's lecture?
Yesterday.
Yesterday, so the formula is exactly identical, nothing changed.
So, but
Yeah,
so there should be a minus sign. You change.
it is there, minus sign, right? It's minus lambda t is there, so minus w, yeah. Now, see, you see the value of w is 13.76. This is for workload 1. So for workload 2, I gave you the value, you need to change this. For the workload 3, you need to change this. For workload 4, we need to change this. So that's what we are working on today.
after running the if we want to see the what is the output of this applying the hyper distribution, then we run the program. Okay.
Maximize this.
This is the length is generated. That means the workload size.
Actually, what he did is that he multiplied every number by 10 or something.
Yeah.
So he scaled it up. You don't need to scale it up. He was playing with it yesterday. I saw.
Okay.
I saw the code. He multiplied 1 by 1,000.
Okay. I just
No, that's fine.
Okay.
What he get, you don't have to get it. That's what I'm just trying to tell you. You may get 0.5 or 0.523. So you got these numbers by multiplying, by scaling it up. One of the problems is that the length is in CloudSim is long. So when you convert it, when you do the conversion from double to long, it always gives you some garbage value.
Now this is okay, sir?
Yeah, this is okay. So you can see that there is 1, 2, 3, 4 big values. The rest are small ones. Okay.
Now this is the second task. Now for the first task is for assigning the arrival time of the task. For this purpose, we have to change data center broker class.
For this one, you only change the value in the cloudlet. You just say this is how long this cloudlet is going to take. But for arrival, you have to go into cloud data center.
Another class. That class is data center broker class. In this class, there is a method named submit cloudlets. We have to change here for implementing the arrival exponential arrival time. Na?
No.
How is it?
Poisson. For implementing, we have taken various types of variable: lambda, arrival time, inter-arrival time, compute time, minimum value. This is the random variable, random class in which we have create a random object for creating random numbers. Here for calculating arrival time, this is the formula, which is exponential arrival time. No? Poisson distribution. Now we have to calculate inter-arrival time. This is the arrival time of first task. Now what is the gap between the both two tasks? which is decided by this value, inter-arrival time.
This is exponential.
This is the exponential time. For calculating the next task arrival time, we have to add these three values, which gives the arrival time of next task. Now, when we run this program, we have different types, different time for. Just a minute. So here shows that the first task is coming 1.5 time. Next task is coming 2.20, 2.70. This is the time for arriving on
This is the arrival time of the cloudlets. The tasks arrive one after another. Okay. So inter-arrival is, the arrival is how many tasks arrive in 1 hour. The rate, okay? The inter-arrival is if you have one task arrive now, what is the next time the next task will arrive? So the Provisioning is basically the arrival time. Every task will have the distribution, Provisioning distribution, to calculate its arrival time. And after the first one, for any other that are coming later, you need to calculate the inter-arrival time. That inter-arrival time plus the current time will give you the next arrival time, and it goes like that. That's what we did here. Now, by the way, many things he has up there is I just left it. You don't really need a lot of things. The random number he was generating there, you don't need it because all you need is two lines: Provisioning distribution for inter-arrival time, and for arrival time, and exponential distribution for inter-arrival time. If you add these two together, it will give you the next task that arrives.
This is the for computing arrival time. This is the equation.
Yeah. So that is that, and then the second one you need. So the random number, minimum one, all those you don't need. So anybody
In the
want?
arrival time, we are just multiplying lambda in the arrival time.
Right.
Second, just line below that. Arrival time is a exponential that parabola Poisson distribution. Then next line,
Yeah.
the line you have selected just below that. Inter-arrival time is just multiplication of lambda to the arrival time.
Minus lambda multiply arrival
Yeah,
time.
because Provisioning is lambda e to the power of minus lambda t.
That is the
Yeah.
what is the rate?
That's the rate, yeah. Provisioning is all e to the power of minus lambda t, and exponential is lambda times the e minus lambda t. That's basically what we did. Yes. And he put a lot of print out statements for many things. I don't know. But this is basically what you need to change to. Now what we want to do is for each one of these, for each cloudlet, to do some work. Now what we're going to do is we will add some big multiplications to multiply or add something, so you will see that how long it takes to finish. Now, anybody wants this code, come and get it.
Send it by emails and
Send it by email.
Okay.
It's only about 4 lines. There is nothing really, but you can send it to you.
Okay. I have a Google group in which.
Yeah. Okay.
Any other question?
It's becoming now me. I always start, do you have a question? And then any other question. He started from bottom up.
Okay. Then sir.
Okay.
You made him expert.
He's an expert now.
Thank you.
Okay, so we will, I will go around and see if you need help. We will let the cloudlet to do something again. Okay, now it doesn't do anything. It basically have that time. We want that execution time. Anyone has any question? No?
ये कोड कितनी की
पावर बैंक लेके आया करो 9 सेल की बैटरी आती है आपकी कितनी 3 सेल वाली होगी बैटरी लेके चलते
Did you do it? No?